Welcome to our
CloudNet Solutions project.
The project created by
Nabil, ZULKARNAIN, Aisha,
and
FARIS.
Scenario 1, DHCP Setup and Security. Let's get started. Welcome to our CloudNet Solutions project. In this demonstration, we'll walk through how we set up and secured a DHCP server using Fedora Linux. The system automatically assigns IP addresses to client devices and enforces network control using MAC filtering, logging, and firewall rules. Our Fedora server is configured with two network interfaces. The first, NP0S3, connects to the internet using NAT. The second, NP0S8, is attached to an internal network named DHCP. This interface uses the static IP address 192.168.100.1 and acts as the DHCP gateway. We installed a lightweight DHCP service called dnsmasq. In its configuration, we defined the DHCP range from 192.168.100.10 to 100. We also set the default gateway and DNS server options. The service only listens on N0S8 and binds to that interface for security. To share internet access with clients, we enabled IP forwarding and configured NAT using firewall CMD and IPTables. This setup allows internal clients to connect to the internet safely through the server without exposing the entire network. To restrict access, we used static DHCP binding. Only ODAC addresses listed in the configuration can receive an IP address. This blocks unauthorized devices, even if they connect physically to the network. Only trusted devices are allowed. We enabled DHCP logging in dnsmasq to record each request, lease, and denial. These logs are monitored using journ-alt-tow, helping us detect suspicious activity and confirm which clients were granted access. On the client, we used an app with a DHCP Discover script to scan for rogue DHCP servers. Only our server responded, confirming that the network is clean and secure from unauthorized DHCP broadcasts. We ensured the DHCP service only responds on the internal interface, NP0S8. We added an IPTables rule to drop all DHCP traffic arriving on other interfaces. This prevents any accidental IP leaks or rogue responses through the internet interface. We tested using a legitimate client, which successfully received an IP. Then we spoofed a MAC address that wasn't authorized, and no IP was assigned. Logs confirmed this denial. All tests passed, including AT, ping, curl, and DNS resolution. Using dig and nslookup, we verified forward and reverse DNS resolution for www.cloud.net. The client correctly resolved the server's IP, and PTR records were accurate, confirming the DNS service works internally. To test Squid integration, the client set the proxy environment variable and used curl to access a web page. The request was forwarded via Squid, and logs confirmed successful proxy handling. System logs from dnsmasq and Squid showed lease assignments, request timestamps, and client addresses. This provides full traceability for network behavior and access patterns. We confirmed DHCP and proxy ports were open only on NP0S8. Firewall rules were effective in filtering traffic. Additional IPTables rules reinforced that only trusted interfaces handled DHCP. All components passed their validation tests: DHCP, NAT, DNS, MAC filtering, logging, and firewall rules. The system is stable, secure, and properly isolated to serve internal clients only. setup is functional, secure, and fully monitored. It serves only known clients, shares internet access via NAT, and blocks all unauthorized activity. This setup is suitable for small businesses and internal labs. Thank you for watching. Scenario 2, DNS Setup Configuration. Let's restart it. Welcome to CloudNet Solutions. In this session, we'll cover how to configure a DNS server using Bind on Fedora. This DNS setup supports our internal network, resolving host names like server.cloud.net or www.cloud.net to internal IPs, and enables reverse DNS as well. First, we install the required DNS server software using DNF. On the terminal, we run bash sudo dnf install bind utils y. This installs bind 9 and useful tools like dig, nslookup, and host. The main config file for bind is etc named.conf. Here, we define the options block to listen on the internal network. Listen on port 53, 127.0.0.1, 192.168.100.1. Allow query, any. We also include our zone files for forward and reverse lookups under the zone section. Now we create our forward zone file, /var/name/cloud.net.zone. This maps host names to IP addresses. We define it as the origin, then set SOA, NS, and A records. At nsoa server.cloud.net, admin.cloud.net, 13H15M1W1B. At nnsserver.cloud.net, server NA 192.168.100.1, www.192.168.100.1. The reverse zone allows IP to hostname lookups. We create per var, named 100.168.192.in-addr.zone. At nsoa server.cloud.net, admin.cloud.net, 13H15M1W1B. At nns server.cloud.net, 1inptr server.cloud.net. To ensure bind can read the zone files, we set permissions. Sudo chung root, named per var, named, *.zone. Sudo con 640 per var, named, *.zone. We check for syntax errors using named checkinf, named checkzone cloud.net/var/name/cloud.net.zone, name checkzone 100.168.192.in-addr.per var named 100.168.192.in-addr.zone. Once validated, we enable and start the DNS service. Sudo systental enable name, sudo systental start named, sudo systental status named. We allow DNS through the firewall. Sudo firewall cmd add service equals DNS permanent. Sudo firewall cmd reload. On the client VM, we point DNS to the server by editing /etc/resolv.conf. Name server 192.168.100.1. We use dig to test forward and reverse lookups. Dig server.cloud.net. Dig x192.168.100.1. Expected results. Forward. Server.cloud.net gives 192.168.100.1. Reverse. 192.168.100.1 gives server.cloud.net. Additional testing tools include nslookup www.cloud.net, host server.cloud.net, host 192.168.100.1. Please confirm the DNS server is resolving correctly on the client side. DNS logs can be monitored using journal named. This shows which clients queried the server, what domains were resolved, and any errors encountered. Common issues include wrong zone file names, incorrect SOA format, or missing PTR records. Use name checkzone and dig plus trace to debug. Always reload or restart bind after changes. In future stages, this DNS can integrate with DHCP by dynamically updating records as clients receive IPs. For now, static mappings are enough for fixed lab environments like CloudNet. We open a browser on the client and access http://www.cloud.net. The Apache page hosted on the Fedora server appears, confirming DNS resolution and internal routing both work perfectly. In conclusion, our DHCP setup is functional, secure, and fully monitored. It serves only known clients, shares internet access via NAT, and blocks all unauthorized activity. This setup is suitable for small businesses and internal labs. Thank you for watching. Scenario 3. NTP Setup Configuration. Let's restart it.
Welcome back to CloudNet Solutions. In this section, we'll configure an NTP server on Fedora. NTP, or Network Time Protocol, ensures that all devices in the network synchronize to the same system time, essential for security, logging, and automation. Fedora uses chronyc for NTP services. On the server, we install it with sudo dnf install chrony y. Chrony offers fast time sync and works well even in virtual machines or networks with fluctuating latency. Next, we configure /etc/chrony.conf. Comment out the default public pool lines and add conf server 0.c entos.pool.ntp.org eburst. Then allow internal clients by adding your LAN subnet. C. Allow 192.168.100.024. We enable and start the chrony service. Sudo system to enable. Now chronic. Then verified status. Chronic sources. This shows the NTP peers, their delay, offset, and sync status. To allow time sync requests, we open UDP port 123 in the firewall. Bash, copy, edit. Sudo firewall cmd add service equals NTP permanent. Sudo firewall cmd reload. On the client machine, we repeat the chrony install and edit the configuration. This time we set the server to the internal IP of the Fedora server. Conf, copy, edit. Server 192.168.100.1 eburst. We then enable and start chrony. To check if time sync is working, run bash copy, edit, chronic sources, and bash copy, edit, ntpstat. If the client shows synchronized to NTP server 192.168.100.1, the setup is successful. Time accuracy will be within milliseconds. Scene 8, final notes, 345 to 444. Accurate time sync is critical for authentication, logging, and system performance. This NTP setup using chrony keeps all systems in sync within your internal network, even without internet access. CloudNet's environment is now fully time-aware, reliable, and secure. Thank you for watching this part of the project.
Scenario 4. Website server. LAMP PHP. Let's restart it.
Welcome to the CloudNet Solutions project. In this section, we'll walk through how we set up a web server using Apache and PHP on Fedora Linux. This server will serve internal web pages and can host PHP applications for internal use. We begin by installing Apache using the DNF package manager, bash. Copy, edit, sudo dnf install attdy. Apache, also known as attd on Fedora, is a reliable open-source web server widely used in enterprise environments. Once installed, we enable and start the Apache service so that it runs on boot. Bash, copy, edit, sudo systemctl enable now attd. We verify its status with bash, copy, edit, sudo systemctl status attd. If it's active and running, the server is live. Next, we allow HTTP and HTTP traffic through the firewall to make the web server accessible. Bash, copy, edit, sudo firewall cmd add service equals HTTP permanent. Sudo firewall cmd add service equals HTTP permanent. Sudo firewall cmd reload. To enable dynamic web content, we install PHP and the PHP Apache module. Bash, copy, edit, sudo dnf install PAFPAH and PAFPAH and CLY. Apache automatically integrates with PHP after installation. We create a PHP test page in the web root directory. Bash, copy, edit, sudo nanovar whummel info PAFPAH with the following content. PAFPAH, copy, edit, PAFPAH finfo. Now, we open a browser and access HTTP 192.168.1001 info PAFPAH. If the PHP info page appears, it means Apache and PHP are working correctly. If DNS is configured, clients can also access the server using its hostname, like http://www.cloud.net. This improves clarity and consistency in internal environments. Apache and PHP now running on our Fedora server, CloudNet users can host internal sites, dashboards, and lightweight applications. This forms a strong foundation for web development and system management within the local network. Thank you for watching this part of the setup.
Testing, validation, and demonstration. Let's we started.
Untuk mengesahkan konfigurasi yang telah dibuat, beberapa ujian telah dijalankan pada setiap servis yang terlibat. Semua servis diuji dan berfungsi seperti yang dirancang. Klien terima dari DAC, DNS result berjaya, masa diselaras dengan DAC, web server boleh diakses, dan firewall berfungsi, sekat trafik tidak sah. Ujian support Mac juga gagal seperti dijangka, menunjukkan keselamatan aktif. Projek ini berjaya dilaksanakan dengan konfigurasi yang stabil dan selamat. Semua servis seperti DAC dan SHAHRUDIN dan Apache berjalan lancar. Rangkaian dalaman kini lebih terurus, otomatik dan terlindung dari akses tidak sah. Sistem sedia digunakan dalam persekitaran sebenar.
Configuration DIG CloudNet berfungsi dengan baik. Configuration IP address berfungsi dengan baik. Configuration host CloudNet berfungsi dengan baik. Configuration DIG Cloud.net null answer berfungsi dengan baik. Configuration DIG CloudNet short berfungsi dengan baik. Configuration DIG CloudNet berfungsi dengan baik. Configuration nslookup cloud.net 1.921.681.1 berfungsi dengan baik. Configuration status firewall berfungsi dengan baik. Configuration name server lookup cloudnet berfungsi dengan baik. Configuration NC's lookup find cloudnet berfungsi dengan baik. Configuration NSE lookup cloudnet berfungsi dengan baik. IP status client from surfer berfungsi dengan baik. Configuration cloud.net info PHP berfungsi dengan baik. Configuration index AHMAD IP address berfungsi dengan baik. Configuration curl IP address berfungsi dengan baik.
Welcome to Web Server CloudNet Solutions service. It was created by our members project Nabil, Jewel, Isa, and Faris from Group 10. Sekian terima kasih.
Okay, ITU sahaja dari kami ahli kumpulan 10. Semoga kita berjumpa lagi.